Hi all, today we are going to discuss about disruptive voltages for the formation of corona. So let us take for example, I am taking two conductors. The first conductor A is carrying plus lambda coulombs per meter length of the charge and the second conductor is carrying minus lambda coulombs per meter length. That means the conductor B is a return conductor. So let us assume the distance of separation between them is D and the radius of the each conductor is R. So let us assume I want to find at a distance x from the first conductor. Let this point P is there. Now at this point P, the electric field due to the first conductor, because it is positive charge, the electric field will be move away. It will be in the direction of from A to B. Let us take, these are lying along the x-axis. Let us assume this is the x-axis. So x-axis. So this will be in the direction of the positive x-axis. This is the electric field intensity due to conductor A. Similarly, this conductor B also superimpose the electric field intensity here. As this is the negative charge, the electric field intensity will be attractive, or we can tell the electric field intensity produced by the second one also will be in the same direction, or we can tell the electric field intensity at this point will be adding, both the electric field intensities will add at any particular point. Let us assume the neutral plane is happening in the center, because one is carrying minus lambda and one is carrying plus lambda. Let us assume the potential difference between them is V. So in the center the neutral plane will come, where the potential will be 0. Here the potential will be minus and here the potential will be positive. So I can write my electric field intensity due to the first one will be equal to lambda by 2 pi epsilon naught into x. This will be in the direction of Ax. The electric field intensity due to the second conductor will be Eb is equal to lambda divided by 2 pi epsilon naught into, and it is at a distance of d minus x with respect to conductor B. So this I can write as a d minus x. This will be in the direction of Ax. Actually the charge is minus lambda and the direction of this Ax will be minus Ax, because we have to take in the opposite direction. So minus into minus become plus. That's why I have written directly. So we can tell that the net electric field intensity at the point, at this point P, due to both the charges, so this can be written as lambda by 2 pi epsilon naught into 1 by x plus 1 by d minus x. This is what I can tell. So let us take it as equation number 1. So let us assume the potential gradient is V dash of each conductor with respect to the neutral plane. Neutral plane means neutral plane is in the center. So this V dash I can calculate by doing the negative integration of electric field intensity. We have already seen in the EMF. So if you don't have the idea, you can please refer to my EMF lectures. I have taught there potential how to calculate. So this will become d by 2. We have to move up to the surface of the conductor, because we know inside the conductor, because it is a equipotential surface or the equipotential line, so electric field intensity will be equal to 0 inside the conductor. Only electric field intensity will be there only on the surface of the conductor. That's why I am taking only up to R. So this will become Ex in the direction of dx. So differential length whatever we are taking. So this becomes lambda by 2 pi epsilon naught into, if you apply this, this becomes ln of x minus ln of d minus x. This range is R to d by 2. So if you are substituting this, this will become equal to lambda by 2 pi epsilon naught ln of d minus r divided by r. So this is the value of the V dash. So from this V dash I can calculate that this lambda by 2 pi epsilon naught, because this can be rearranged, will be equal to V dash divided by ln of d minus r divided by r, because equation number 2 is rearranged. Let us take it as equation number 3. So now what I am doing, I am substituting equation number 3 in equation number 1. So when you substitute in the equation number 1, so this can be written as Ex will be equal to V dash divided by ln of d minus r divided by r. So lambda by 2 pi epsilon naught I have replaced, multiplied by d by x into d minus x. If you substitute that one, 1 by x minus 1 by d minus x, if you simplify it, you will get the answer like this. So since we know that d is far greater than r, so this gives rise to this d minus r, I can approximate to d, or from this I can tell that the value of Ex will be equal to V dash divided by ln of this d minus r will become d, this will become d by r multiplied by d by x into d minus x. So let us take it as equation number 4. So how this value of the V dash will be there? So the value of V dash will be equal to your supply voltage for divided by 2 for single phase transmission line, and this value will be equal to VL divided by root 3 for the 3 phase line. Because in the single phase line, one conductor will be positive conductor, second conductor will act as a return path. So the potential will become 0 in the center. So how this comes, you can please refer to the EMF there I have taught there in detail. So from this equation number 4, we can make some observation that this electric field intensity Ex is inversely proportional to the value of x into d minus x. So we can tell that as the value of x is increasing, so automatically that Ex is going on decreasing, and the value of this Ex will be maximum at the surface of the conductor. So we can tell that this Ex is maximum at x is equal to r, which we generally represent by the gradient. So we can tell that the gradient will be maximum at the surface of the conductor. So therefore I can tell that the maximum value of the electric field intensity, or which we also called as the maximum value of the gradient, will be V dash divided by ln of d by r multiplied by d by r into d minus r. As we know, the value of d is far greater than r, so this can be approximated as V dash divided by r into ln of d by r. So this I can take as equation number 5. Getting it? So the value of the potential gradient at which the ionization of air takes place under normal temperature, generally it is 25 degrees centigrade, and a pressure of 76 centimeters of Hd, and without impurities, is generally equal to 30 kV per centimeter or 21.1 kV per centimeter RMS value, and this is denoted by the term G naught. So from this I can write that voltage required to ionize the air will be V dash will be equal to R into G naught, because whatever we have derived the V dash, so there I have substituted this. So R into G naught into ln of d by r. So let us take it as equation number 6. So the dielectric strength of air, because the temperature is not constant, that temperature will go on changing. So if the temperature is changing, we will add one more parameter that is called as delta, which is air density correction factor. This air density correction factor will be equal to B divided by 76 multiplied by 273 plus 25, this is the normal temperature, divided by 273 plus T, because it is represented in kelvins. So this will become 3.92 B divided by 273 plus T, where B is the barometric pressure of HV and T is the temperature. So I am providing the complete handwritten material in the description below. You can please download from there. Here you try to understand the concepts what I am doing. So we can summarize that this value of V dash will be equal to R into G naught into, we have to multiply with this delta to account for change in the temperature as well as the change in the barometric pressure. So this will become equal to G naught into delta ln of d by r. This is my value of voltage we got. So let us take it as equation number 7. So from this I can tell that the critical disruptive voltage, so it is a voltage at which the electric field intensity at the surface of the conductor exceeds the critical voltage and corona starts forming. This surface of the conductor also affects the critical voltage. Which type of surface of the conductor is there, that also affects it. Generally the roughness of the conductor surface causes a distortion in the electric field and gives rise to local regions of high potential gradient, resulting in decrease in the value of gradient voltage. So generally we know the conductors are made up of the stranded conductors as well as this dust and dirt comes and accumulate on the conductors, that will further increase the irregularity factor. So stranding condition of the surfaces are taken into account by use of a factor called as surface factor, or it is also called as the roughness factor. That roughness factor is given by the name m naught. So if you are considering this, so we can tell this the critical disruptive voltage will be whatever we have derived before. So that's the same thing I am writing, R into G naught into, one more factor is added there, m is added now, multiplied by delta into ln of d by r. So this is called as critical disruptive voltage. It is nothing but the voltage at which the corona will start forming. That means only at the surface. Please remember this. So here the value of m will be 1.0 for smooth conductor and this value will be 0.93 to 0.98 for rough conductor. Okay, and the value of the delta will be 3.92 into B. B is the barometric pressure in centimeters of Hd in mm of Hg. Okay, it is in centimeters of Hg only. 3.92 into B divided by 273 plus T. T is the temperature in degree centigrade. So now coming to visual disruptive voltage. Visual, it is also called as visual critical disruptive voltage. So it is given by V suffix V. So I have told you that on the surface of the conductor, if on the surface this electric field intensity or the gradient at this point reaches the value of G naught, the corona will start forming. But this value is equal to 30 kV per centimeter. So we know the electric field intensity on the surface, if you are plotting it, at the surface the electric field intensity will be maximum, and as you are moving away the electric field intensity is decaying. This is the electric field intensity that is decaying, or the G is decaying. So minimum 30 kV per centimeter is required. So 30 kV per centimeter is only on the surface. Corona will form, but only in the small layer. So because of that the charge carriers will start moving, but they cannot get the sufficient energy, because outside this region the potential is less or the electric field is less. So they will not get the sufficient energy to dislodge more charges and form the corona. So in order to form the corona, so this value of the 30 kV per centimeter should be at some distance little farther than the surface. That means thus G naught should happen at some distance farther from the surface. So then only up to here the air will get ionized, then the corona will form, and we can visualize this value, or otherwise we can tell that the visual corona will come only if the value of G naught is having some distance little far from the surface of the conductor. So obviously we can tell if G naught is here, automatically the value of the gradient on the surface will be greater than this. So the value of the surface will be, it will not be equal to G naught, this will be equal to Gv. That means if the value of gradient at the surface of the conductor is equal to Gv, then only the visual corona will come. So the energy gap between this Gv and G naught, the gap between the Gv and G naught, or the Gv minus G naught, so this value is called as energy distance. This value is called as energy distance, and the scientist Peake has proposed a equation for empirical formula for getting this. So the value of Gv will be equal to G naught multiplied by delta into this energy gap will be 1 plus 0.3 divided by square root of R delta. This will be in kV per centimeter. Remember here I have written the equation in kV per centimeter. In some books they may write in volts per meter like that. So in that case the values may change. So please remember that everything I am doing is in per centimeter basis only, so that confusion will not be there while solving the numerical. So here you have to remember that whatever values you are substituting, like the radius, so it should be in centimeters only. So that result will come in centimeters. So let us now see what will be the final value of the Vv because of this. So because of this I can write my value of Vv is equal to R into that G becomes Gv now, and this M will not be M like before, it will become Mv for getting the visual corona, ln of d by r, or this I can write as 21.1 times of mv into r into delta into 1 plus 0.3 divided by square root of r delta ln of d by r. So this will be kV, this value will be in RMS. So here you have to remember that whatever value this r, d, all these are mentioned in centimeters only. Please refer this clearly. So here you will get out what is this value of the MV. Actually the value of the M is not constant if for the case of visual corona. What happens if your conductor is irregular? Let us assume some irregularities are there. So because of the irregularities the electric field will get disturbed. Because of this the corona, visual corona will happen on the wherever the peaks are there. So there the corona will form initially. So this corona is called as the local corona. First the local corona will be formed. So if the gradient is further increased, then the corona will spread to the nearby areas, and then the complete corona will be there, which is called as the decided corona. So we can tell this value of this MV will be equal to 0.72 for the case of local corona for the case of standard conductors, and this value will be equal to 0.82 for decided corona. Decided corona means the corona will come to the complete conductor. So it should be greater. That's why it is given as 0.82. In the case of polished wire, it will be equal to 1.0 only, like before. This is the case of polished wire, that means without any type of dust and other things. If the conductor is having some roughness, little bit of roughness, this value will be 0.93 to 0.98. This is for rough conductor. This is for rough conductor. So I think up to here it is clear to you. So the difference between critical disruptive voltage and visual disruptive voltage is, critical disruptive voltage happens when the value of the gradient on the surface of the conductor is equal to Z0, and visual disruptive voltage will happen if the value of this G0 will happen somewhere little far from the surface, and this gap should be equal to the energy gap. The energy gap is given by this formula 1 plus 0.3 divided by square root of R delta. This extra term should be added to the value of this G0, multiplied with G0 to get the actual value. That means what will be the value of G at the surface of the conductor, which is given by GV. I hope it is clear to you. So let us take one small example so that the calculation and other confusions will be completely clear to you. So I am taking one example. It is given that find the critical disruptive voltage and the critical voltages for local and general corona on a 3-phase overhead transmission line consisting of 3-phase, so it is already 3-phase mentioned there, right? So 3 stranded copper conductors spaced 2.5 meters apart at the corners of an equilateral triangle. Air temperature and pressure are 21 degrees centigrade and 73.6 centimeters of Hg respectively. So here I am writing on the glass screen, so that's why the handwriting is not coming properly. You can please download the handwritten material from the description of this video. So here you try to understand what I am telling only. So the conductor diameter, irregularity factor and surface factors are 10.4 mm, 0.85, 0.7 and 0.8 respectively. This is what is given. So let us try to calculate. So first one, to calculate the disruptive critical voltage. So disruptive voltage will be 21.1 into M into delta into R into ln of d by R. So for that we need the value of delta. Delta will be 3.92 into B divided by 273 plus T. So this I can write as 3.92 into this barometric pressure will be 73.6 divided by 273 plus temperature given is 21. So this will become 0.9813. This one we got. So now substituting this one in VD, so we'll get it as 21.1 into 0.85 multiplied by 0.9813 into 0.52 ln of 250 divided by 0.52. So this will be equal to 56.5 kV. This is what we get. So the line value, so VD line value, this line value we will get by multiplying with root 3. So root 3 times of 56.5, this will be equal to 97.89 kV. So now the visual disruptive voltage will be equal to 21.1 times of M delta R into 1 plus 0.3 by square root of R delta into ln of d by R. And in the numerical it is mentioned The two things are mentioned there in the numerical. You can see here one is mentioned as 0.7, second one is mentioned as 0.8. So they have given the names as the irregularity factor and the surface factor. Actually these things are represented for the case of local and the decided coronas. So we have to take this as 0.7 for local corona, and this value will be equal to 0.8 for decided corona. So 0.8 is given there, that 0.8 we have to take for the decided corona. So let us try to calculate what is the value of VV for local corona. So VV local will be equal to 21.1 into the value of M will be taken as 0.7. So this will become equal to 0.9813 into 0.52. This will be 1 plus 0.42. If we substitute, this will become ln of the distance of separation between the conductors. The distance between the conductors divided by the radius. So if you substitute this, you will get your answer as 66.07 kV. So if you are to represent this in VV local for the case of line value, so line value will be 66.07 into root 3. This will become 114.44 kV. So similarly, if you want to calculate VV for decided corona, so decided value, this value will be equal to 0.8. So from this I can calculate 114.44. So this value I am multiplying by 0.8 and dividing with 0.7, because above one is coming, we are taking it as 0.7. So here you have to take as 0.8. So this will become 130.78 kV. So this is line to line for the case of general corona. So in this way you have to take, you have to observe here whatever the values you are taking, that value should be taken in centimeters only. So please remember this one. I think this is clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you very much.